Hi everyone, how's it going? My name is Kevin. I'm the COO at Hohonu. And before I introduce the panel being led by Dr. Todd Crowell, I'm going to briefly talk about the services we provide at Hohonu. Hohonu is a technology company that provides reliable, cost-effective, hyperlocal water monitoring for tides, floods, and sea level rise in order to empower communities and citizens to better understand their risks through real-time accessible data. And one thing I have to say is that I was born in Honolulu, Hawaii, and being 6,000 miles away, in a room full of people who have very similar values and motivations to help the environment is very inspiring. Hohonu was actually created to help with the restoration of dozens of ancient Hawaiian fish ponds that existed centuries before. And so we're mostly a team of earth scientists whose mission is to democratize access to ocean observing technologies. What that means is we collect the most amount of reliable water data in natural environments along coastlines, rivers, and streams, both through hardware and software. And we deliver that to stakeholders, including governments, to help them build more resilient communities. We deliver that data through a variety of different ways, from APIs to our web dashboard to installable widgets. And last year, we deployed 60 water level sensors across 8 coastal states, including 5 here in Florida. And we just raised a pre-seed round in order to support that expansion. We've received about $4.5 million in funding, about half of which has come from National Science Foundation as well as NOAA. And so if your community wants to have a more data-driven approach to sea level rise and tides management, then please don't hesitate to approach me during the event. And so without further ado, I'd like to introduce Dr. Todd Crowell. Dr. Todd Crowell is the director of the FIU Institute of Environment, one of the university's preeminent programs. Crowell has been the principal investigator at FIU on Crest Cache and has published more than 60 peer-reviewed articles over the course of his career. And he has presented important solutions to environmental threats to the White House and other important decision makers.
Good morning. I'm going to keep this short. We're a little bit behind on time. You heard Aurelia say we are data driven. The management strategies we take are based on the data we have. And so I'm really proud to introduce this morning's panel. We have 4 great scientists who are going to provide us with an update on data. We'll start with Pam Sweeney from Durham, who's going to give us sort of the county report card, the state of the Bay. Then we'll go to Piero Gardinelli, who's going to talk about some of the data gaps, what we don't understand. We've heard the term PFAS said a bunch of times. There are a lot of emergent pollutants and chemicals we need to worry about from a human health perspective. And Piero's going to talk about some of the research he and his group are doing. Then we're going to go to Kelly Ralston from the Tarpon Trust, who's going to talk about some of the megafauna, more of the wildlife perspective. And then we're going to end with Jim Forkran, also from FIU, who's going to talk about what does it mean to be successful? What do we really have to do? And Aurelia showed that great slide. If we're successful, seagrass comes back, right? And that's one of the ecosystem responses that we're looking for. So that's what we have in store for right now. And panel, come up.
Good morning, everybody. Thank you for the introduction, Todd. Next slide. Unless you prefer Piero, which is that's fine too. But as we wait for that, the next slide really is meant to sort of center the few moments that I have with you all to acknowledge where we are. And I appreciated this morning's opening, so I think I'll just build upon that. But I just want to note that our proceedings and the natural resources that we will be discussing today occur on the ancestral and traditional lands of the Seminole, Miccosukee, and Takehome people. And what you see here is a snapshot of a digital installation by Houston Cypress of the Otter Clan of the Miccosukee tribe. And it's called What Endures. And I think that today what endures is each of us, our community and our bay. Thank you. Thank you. Next slide. Ooh. So as we contemplate the state of the Bay, I'd like to place ourselves a little bit in sort of space and time, and not just where we are today, but where we've been. So let's talk a little bit about how we've changed our landscape. What you see here on the left, of course, depicts not only a heavily developed South Florida and specifically Miami-Dade County, but the work that's endured to help protect it. And first, I just want to note that somewhere between 5,000 and 2,500 years ago, the Bay emerged and became what we know today as the estuary that it is, sort of two barrier islands that have had the Bay fill up in between them. Two series of land masses, the barrier islands to the east, and of course the mainland to the west. And somewhere 35, 40 years or so after we started to develop this landscape, we really started to make some observations about the ways in which we've significantly changed this resource. And around that time, when other environmental movements were taking off, not only in this country, but in other parts of the world, in the early to mid 70s, the same thing was happening here in South Florida. And what you see here depicted in the hot pink color is in our county here, we have 2 state aquatic preserves, and we have our aquatic preserve team here today that is managed by the Department of Environmental Protection. And in the middle of those 2 aquatic preserves, we have the national park that so many of us love and have spent time in, Biscayne National Park. To the south, we have the Florida Keys National Marine Sanctuary that overlaps with those managed areas down in Card Sound. And this was really through the efforts of folks just like you here in the room that endured and that were able to sort of preserve and protect this estuary. And today it is regarded as one of the most protected estuaries in the state of Florida. But let's talk a little about how we've changed that landscape. And what you see on the right is really sort of just a high level graphic to kind of illustrate the ways in which water used to be received by this system. So we are historically part Biscayne Bay of the Kissimmee, Okeechobee, Everglades watershed. And that means that water historically sort of naturally came from those chain of lakes through the Everglades ecosystem, what we know, of course, as the River of Grass, taking years to really reach the peninsula of the state of Florida. And we received some of that fresh water on the East Coast. And of course, the West Coast also received some of that freshwater flow. But through our development of having to sort of build on these wetlands, we've effectively figured out a way to do it so well that we can sort of live in this atmosphere and in this environment without flooding. And that takes a lot of work, takes a lot of engineering by some brilliant minds in the room that have helped manage how that water moves throughout this ecosystem, but it really has changed the Bay. And so we are, as many of you have been involved in over the years, over the last 20 to 30 years, sort of re-engineering this ecosystem through the Everglades restoration projects that this community will see the benefit of. But that's also meant some pretty significant impacts for Biscayne Bay. So I wanted to talk about that a little bit with our next slide. And really, I want to specifically talk about what that means for water quality. We know that water quality also has a larger impact on the health of the Bay overall, which we'll talk about in a moment. But we want to just highlight for you a little bit about what that means. So water quality and quantity, how we move water off the landscape and thinking about that differently is going to be key to recovering and restoring Biscayne Bay's resources. It's not just about moving water quickly off the landscape so we can continue to live and thrive here, but we've got to think about how we do that differently, because we know that turbidity, stormwater runoff, and all it contains, be it pet waste, agricultural byproducts, like fertilizers, hydrocarbons, oil from our car, other material that really was never meant to be received by the estuary, namely nutrient enrichment, right? Nitrogen and phosphorus. We're going to hear a lot about that today. And also bacteriological indicators from having so many people live in such a condensed area and a city that's fairly aged in terms of its infrastructure, some of which parts of our city, of course, our county, are not using sanitary sewer services. So there's also that potential impact that we're currently investigating. And just knowing that there's sort of this natural sheet flow that isn't there anymore. And what does that mean for the species that depend on that salinity regime, and be it plants or animals? There's also, of course, in more intense recreational uses. This is something that we talk a lot about in Miami-Dade County and with our partners, many of whom are in the room, whether that's increased boat traffic, increased use of our spoil islands, just folks using the Bay differently and more intensely in new ways. has really come to a situation where we do experience habitat loss, as Arella pointed out earlier. We've seen some significant ecological shifts and even collapses. And that is not just in seagrass, but also our hard bottom communities, which are comprised by seagrass, sponges and corals, as well as our mangroves and coastal wetland habitat. Not to mention what this means in terms of development for public access, be it visual or physical, and equity issues around access to the bay. Next slide. So let's use the Biscayne Bay report card to kind of talk about where we are when it comes to water quality and our seagrass habitat. So several years ago, through the leadership of then Daniela Levine Cava, we were tasked with kind of coming up with a tool that could be used by the public and digested by the public as a way to sort of understand the state of the health of their bay. And we did this by using a stoplight approach, sort of a red, yellow, green. And we've really tried to do the most that we can within those three color blocks, because to say you're fair, you're poor, you're good can be different from year to year. And those differences don't necessarily reflect a giant ecological improvement or a giant ecological collapse or decline. And so we wanted to just provide some context for the audience in terms of what the report card can tell us. And as Piero and others today will talk about sort of the ways in which we know we're missing some information that can help us make this a more rich and more helpful tool. So the parameters that we've included in our report card, very similar to some of the other estuarine report cards you might have heard of, like the Chesapeake Bay report card, Charlotte Harbor on the West Coast, include things like habitat, seagrasses, sponges, as well as water quality parameters, namely phosphorus, nitrogen, and chlorophyll, as well as some bacteria indicators, which is both the freshwater indicator, Escherichia coli, and the indicator that we know can persist in marine environments, which is Enterococcus, and water clarity as a measure of both water quality, but also indicative of how our habitat will be doing with the state of the water clarity we have. And what you see here in the 2022 report card is concerning. We have a lot of areas of the bay that remain in what we would consider fair condition with some changes, right? So you see some yellow to green, you see some red to yellow, and I want the audience to sort of take these with an understanding that there can be water quality improvements. That doesn't mean you're going to see an ecological shift reflected right back at you, at least not immediately, right? And where we do see some increases in seagrass habitat, we're trying to understand the ways in which that's manifested. And I'll talk about that in a second. So next slide. So if we dive a little bit more into the water quality side of our report card, what I have for you here is just a snapshot of total phosphorus, total nitrogen, and chlorophyll. The bigger picture here is, again, the most northern basins in Biscayne Bay, those that are north of the Rickenbacker Causeway, are of concern to Miami-Dade County and its partners. We know that the ways in which we are not meeting the state's criteria year after year, and the ways in which that can impact resources, including seagrass habitat and all that depend on that habitat, recreationally important species, commercially important species, is something that we're taking to heart with the initiatives that we're undertaking. So this is really just something that we wanted to show to you. You have access to. This is available, of course, to the public through miamidade.gov/Biscayne Bay. And this is sort of a way that we can help communicate what we're seeing reflected back at us in our data. Next slide. So if we take a little bit of a deeper dive, I just wanted to take the opportunity to show you how we look at and interpret some of this data. And one of the most poignant snapshots is of the fish kill. And so to sort of pick up where Arella left off in terms of the ways in which the information we captured just before the onset of the rains that summer of August 2020, when the fish kill happened, and just after, really tell us a lot about what's going on in our canal systems that can contribute to, but isn't the only contribution, of things like nutrient enrichment to the bay. And what you see in this graphic to the left of your screen is basically all of our stations that we collect water quality data once a month in the stretch of the Little River. And that's up in the north part of the bay. What you see to the left of that graphic are the stations where we collect water quality samples out in the bay, so out in the estuary itself. And what I want you to make note of is the May lines, that blue line, where we are still above the threshold of what, if we were to apply the state's nutrient criteria for the bay in the canal system. There are no nutrient criteria in the canal system, and we're working on that. But if we were to apply that criteria in that tidal portion of that system, we still would be above that dotted purple line. We'd still be in exceedance of what the state would consider a threshold for phosphorus input into the bay or into the system. into the system. What I want you to look at next is that orange line, which represents June, which was the first, and it was actually torrential downpour of the season that we captured happenstance because of the timing of our monthly sampling. And what I want you to note is that the threshold of that dotted line is about 12 parts per billion phosphorus, and it exceeded 50 parts per billion phosphorus with that first flush of rain. Now, again, beyond that line in the bay, we see that phosphorus assimilated, and Drs. Gardinelli and Forkman are going to be able to talk to you a little bit more about what that means for these habitats. But we know that nutrient is going somewhere. We see chlorophyll levels going up. We see seagrass being impacted by consistently sort of taking up and assimilating these nutrients. So what does that mean for the future of the bay? Next slide. We know that seagrass habitat, which is what you see a snapshot of here as part of our 22 report card, is also of concern. What you see on the right is a snapshot of our decline in seagrass habitat report that we put together per a request from our Board of County Commissioners about 2 or 3 years ago. And what we know is that in the northern part of the bay, specifically the Julia Tuttle Basin, we've lost over 80% of the seagrass in that basin, as Arella indicated with that time series of photographs she shared with you. And the two images that are in the middle of your slide are really meant to help you kind of see it how we see it. We're looking at the fact that since 2009, the density of seagrass has gone down, and we haven't seen that recover to the levels at which it was prior to the die-off, but we are seeing some recovery. And that could be because we are seeing some macroalgae come in, we are seeing some stabilization of those sediments, but we haven't seen that seagrass come back, and we know that seagrasses can grow in that basin. What you see in the bottom graphic there is an increase in macroalgae, but not necessarily a requisite increase in total seagrass. And so this is something that we're keeping a close eye on. Next slide. Visually, this is how it looks when our noses are in the water or when our eyes are in the sky doing our manatee surveys. So this gives you sort of a more up close kind of look at what this Julia Tuttle Basin looks like, where the initial fish kill took place. The picture you see on the left was the summer, excuse me, that wasn't 2019, that was 2017, pardon me there. These are kind of jumbled, but what you see behind you is an image from 2017. So we've got 2019 and 2017 sort of juxtaposed. This is looking at the Julia Tuttle Causeway, where we had seagrass habitat in the bottom left corner, albeit starting to become impacted, whereas just a few years later, it was completely denuded. And so this is something that we track through our over 500 random polygons, where we go out every summer and spring to look at the status of the seagrass in the bay. Next slide. So what's next? We want to talk to you a little bit about, and I think we'll go through this more a little bit over the course of the day, but there are a host of projects, programs, and policies, a series of words that Mr. Hefty has left in my brain that we are thinking about, thinking through, working through our partnerships, to put together. And of course, part of that stems from that Biscayne Task Force report, as Arella mentioned, the governance structure that now sort of rises above that report and helps keep it, help us keep us accountable, everyone in this room, and the leadership of Miami County. And through those series of projects and directives, we've been able to apply for grant funding, and we're grateful to our state partners at the Department of Environmental Protection for seeing the potential and the ideas that we and our partners had in order to investigate these sources of nutrient pollution and other pollutants. We have our own sort of internal action plan that we're implementing that includes things like innovative technology, both in the stormwater realm, but also improving the ways in which we can in real time understand what is going on with water quality. And I'll leave it to these gentlemen to talk about that. And lastly, of course, Mayor Levine Cava and our county commissioners who have their own ideas that we're sharing and implementing projects through. Next slide. So we know that it's more important than ever to understand what's going on with our ecosystem, not the least of which reason is there are going to be things that we can control, and there are going to be things that we can't control. Many of the things that Hardeep mentioned earlier, right? Sea level rise, our country experiencing some of the highest or the most significant heat wave and highest indexes we've seen on record in the face of things that we know we can control. We know we can reduce and eliminate pollution if we can find it and understand it. And we know that this is going to be an effort that is going to be undertaken by our community and our partners as well. In Miami-Dade County, we know that our role here in the water resources section, a newfangled section that Mr. Hefty organized with our county leadership, and our mission is to investigate those sources of pollution, break down some silos, and also shift some paradigms. And so we're really excited about that work. Something all of us can do is go out and purchase the Biscayne Bay license plate, and Arella would not forgive me if I didn't mention that today. Next slide. And I also want to mention that our fertilizer, the county's fertilizer restrictions are in place May 15th through October 30th. So I just wanted to make that clear. And I just want to thank you for your time this morning, and I'm here for any questions you might have today.
Okay. Thanks so much, Pam, and thank you and Durham for everything you guys do. Next, we'll introduce Dr. Piero Gardinelli, one of the associate directors in the Institute of Environment and environmental chemist extraordinaire.
Thank you. I should be able to click through the slides. Let's try this. Should. Well, thank you, everybody. So I was given this title and then I walk away from it, but I'm going to try to talk a little bit about each one of these things and hopefully entertain some questions for later. But before I know we have a very limited attention span, I'm going to start with the take-home messages. Okay, so this is it. We are making progress. Hopefully, everybody in this room is on the positive side, so we are in the right track. We do need to use novel technology. Phosphorus is one of the most boring elements in the periodic table. Okay, and we're using technology that was developed in 1962. We can do better. Okay, we need to measure other things, and I'm going to go to a quote that you're going to remember, but we need to measure other things. We have to address the critical data gaps that we have, and I'm going to be selfish on this part. I'm going to show you the ones that matter to me, and then we all need to share information openly, transparent, 2 ways. And then, yes, we need to have a conversation, but we need to listen to what the other folks are saying. Okay, so please remember that. And then for us to make some more progress, we need to think out of whatever the box we're fixed in. So let's go and play with this thing. So water quality. Nobody has put a definition of what quality is. So I'm going to remind you what that is. It's a measurement of some property of the water that is meaningful to something. Okay, if we don't measure something that is meaningful to something, it wouldn't matter. But more than that, it needs to be tied up to some kind of standard. And that's how we regulate things. All right. So we're doing great, except that I'm going to take on her deep take and say we can only manage what we measure. If we don't measure things, we cannot manage anything. All right. So keep this one in mind. Phosphorus, my good friend. We do have criteria for the watersheds. We're grateful that the state did have the conversation. We developed the criteria and all that. Pick up the lowest one you have there, 6 parts per billion. Okay, just remember the 6. Our detection limits are between 0.7 and 2. Okay. I'll tell you, if you go to the doctor to measure something and your detection limit is that close to where you're trying to measure, you're going to be questioning the results. All right. So we need to develop techniques that are much lower than what we are measuring right now. It's the gold standard. Okay, I'm not blaming anybody, but we need to invest in new technology. So that's one problem with phosphorus. Now, flows. Most of the flows that we use to calculate everything is based on the district data. Grateful for the district to have all the data, but it's the data that the district collects. We put the crest buoy in the Little River for a couple of months. I'm not going to bother you with data, but the left side are the daily average flows in the Little River. The flows are always going out in average. So the river is always putting water out. If you try to do a correlation between the district data and the data of the buoy sitting in the river, there is a correlation, but I want you to see that when the gate is closed, we still have some flows going out of the river. So if I'm going to try to model something in the bay and I'm using the gate as my flow, I'm going to be short in my estimation. So again, we need to put technology in there. We need to have real-time data. We need to measure things where it matters. So we can do that. Now, I love this quote from Donald Rumsfeld. So people ask me all the time, yeah, can you detect the water that is coming from septics? Well, yes, if I measure everything that comes from the septic, right? If I don't measure anything, the answer is no. Can I detect the septic just with phosphorus? No. Okay. I have to measure something else. So Donald Rumsfeld told us this. There are non-knowns, the things that we know. There are knowns, unknowns, just to say things that we know that we don't know. And then there's unknown unknowns. As an analytical chemist, is kind of a challenge for me to explain how you're looking for things that don't know what you're looking for. Okay, but we do that. Okay? So let's do a little bit of this. I was a really young faculty here in the early 2000s. Went to the Miami River. They told me it's the most polluted waterway that we have in this area. Much better than the Houston Ship Channel, I have to say. But we did caffeine. The first wastewater indicator that we tried here. Now, surprisingly, concentrations in the river were higher than concentrations in the main bay. We tried to make a correlation with coliforms and all that. We couldn't, just because we didn't have enough data, and caffeine probably was not the best or the most sensitive tracer that we can use. So we kept working, and thanks to all of you that drink diet sodas or sugarless chewing gum, a number of things that have Splenda. Splenda, to me, I've been corrected before, I call it soluble plastic. It doesn't really degrade or anything like that. We just eat it and it goes in. Wastewater treatment plants don't do anything with it. It ends up in the water. We can measure it. So the dots here is the only thing that matters. A red dot is an impacted watershed. A green dot is something that is not impacted. The middle of South Bay is usually nice and clean. Every tributary that we measure brings Splenda into the bay. Does it bring something else? Absolutely. Okay. Do I have a relationship between Splenda and the septic driven phosphorus? No, I don't. Okay. But we're working on it. So one snapshot. Then the forever chemicals. This was published in 2022. We do have perfluorinated compounds in the waters in the bay. We have perfluorinated compounds in the drinking water. Now, if we concentrate on the bay, and that's why I took up this is the graphical abstract from that paper. If you want, the reference is out there. Concentrate on the bottom right graph. The names there should be very familiar to us. BC, the Biscayne Canal. LR, the Little River. MR were the stations in the Miami River. They are the highest concentrations that they were measured in this study. The distribution of different things in the bar are different. So I'm not saying that they all contribute the same thing. Sources are different in each one of the tributaries, but once again, the tributaries are bringing stuff from the land into the bay. So that's where we need to put a lot of effort. All right. I don't know how many of you are familiar with Garmin Connect. This is my watch. So what you have on the right side is my swim on May 17 out of Hobby Beach. So I love to swim in the bay. So the question is, it's okay to swim in the bay? And the answer is yes, okay? And then what you have in the graph is the coliform concentrations are reported by the state database. This is from 2020 to 2018. And things that are in yellow and red are the beaches that we go where there are violations or there are advisories due to bacteria. The one that I swim the most is the one with a little arrow in the middle. So I have 10% probability of swimming in something that has elevated bacteria. So this is where I'm completely selfish now. So the question is, what is it? Where is it coming from? Can I predict it? And so on. So we dig into this data set a little bit more, and this is what this graph is. Now you have the same data on the coliforms. Now you have all the years, all right? So we were looking into, well, is there a trend with the summer? Is there a trend with rain? And we couldn't find many trends because the data is pretty scattered. But in the last years of this data set, the concentrations, or at least the median or the average of the concentration, have steadily been increased. So again, being selfish again, now I want to know all this stuff, all right? Is this real? Should I keep looking at the data? Is it a really increase on the bacterial count at the beach where I swim? But most important is, what are they? Where are they coming from? What's the source? Can we just fingerprint them and figure out if this is from people, from dogs, from manatees, from, I don't know, we have to figure that out. We are doing that, but it's taking a little bit of time for us to get there. So, and then they asked me to talk about plastic, and there's a bunch of it here. Do you know what it's in common of all the plastic that is in these bags here? That they all float. Okay. Now, not all plastic float. So this is my take-home message here. So this is a graph of the density of the materials at the bottom, and then all these nonsense names on the side are the types of plastic. Then there are two lines there, a green line and a blue line. That's the density of canal water and the density of the bay water, give or take. I'm not going to correct for temperature, but so anything that is on the left side floats, anything that is on the right side doesn't float. Are you surprised of the things that are on the left side? Like your typical PET water bottle that is made of nice recyclable plastic. If you take the cap off and you fill it up with water, it does not float. So how much of that stuff is out there? We absolutely don't know. We tend to concentrate on the plastic bags, the styrofoam containers. Why are the styrofoam containers, the bad thing? Because they're foam. Your flip-flops will float as bad as the styrofoam container. So that's the crock that is out there. So again, my point here is we're all fixated on the things that we see floating, which is a great thing that we see the pollution and we try to address it. But there's a big chunk of the plastic materials that end up not floating at the bottom of the bay. And frankly, we do very little for it. So do we have monitoring programs for plastic debris? Very few of them. We collect a lot of trash. Yes, sure. But we need to start looking at other things that are not just the floating debris. And that's all I have for you. So thank you very much.
Yeah, we started late. Okay, thank you very much, Piero. So from molecules to organisms, Kelly Ralston from the Bonefish and Tarpon Trust.
Thank you and good morning. I'm Kelly Ralston with the Bonefish and Tarpon Trust, and it's a real pleasure to be here today. Really appreciate Pamela and Piero kind of setting the stage for kind of the interconnections between water quality, habitat, and our fish and wildlife populations here in Southeast Florida. I want to start with the take-home message. I thought that was a great idea, that we are making progress in addressing all of these issues, and also in better understanding that interconnection between habitat, water quality, and our fisheries in particular. It's not a one-to-one ratio, as Pamela mentioned, and so there's a lot of intricacies that we as scientists and policymakers need to better understand to make informed decisions. We've seen parts of the bay that have had significant habitat loss and poor water quality. Pamela highlighted the fish kills. We've had algal blooms, seagrass loss throughout the bay. And so what I'd like to do today is kind of highlight some of the ongoing and current issues affecting our fisheries and wildlife as we understand now, just in the brief time we have together. So from a marine mammal perspective, manatees are always foremost in most people's minds, and we've had a lot of press about manatees this year, given the unusual mortality event a little bit north of here in the Indian River Lagoon. And looking at 5-year mortality averages for manatees in Biscayne Bay, we are elevated for 2021. So the average number is 18 per year, and in 2021 we saw 31 carcasses that were collected in Biscayne Bay. However, it's difficult to necropsy a lot of those, and so a direct cause and effect is difficult to establish. But the rationale or the thought is that a lot of those manatees came down from IRL to Biscayne Bay already stressed because of the ecological conditions there, and that's why we saw that elevation. Regarding dolphins, there was a 2000 study on PCB presence in Biscayne Bay, and found that They were present and actually in dolphins in Biscayne Bay and 5 times higher in the north side of the bay than the south side of the bay. So those are kind of some areas outside of my expertise on the mammal side of things that I wanted to make sure that you're aware of. Looking at our fisheries, BTT has been particularly concerned about the impacts of water quality on our fisheries, and we're happy to support research from FIU, Jen Rahage's group, looking at pharmaceuticals in bonefish in Biscayne Bay and throughout Southeast Florida. And not surprising to anyone, they are present in bonefish tissue in Biscayne Bay. And in fact, over 58 individual pharmaceuticals were found in bonefish tissue. So that's concerning. In addition, we found an average of 8 pharmaceuticals per fish in Biscayne Bay and 11 pharmaceuticals per prey item. So we actually looked at the things that they're eating. So that's the shrimp and the fish and the crabs. In addition, over 61% of those fish in Biscayne Bay exceeded what we will call the therapeutic threshold for pharmaceuticals. And so that's the concentration at which you would expect changes, actual physical changes to occur or behavioral changes to occur in those fish, meaning that they have changes in their spawning behavior, in their feeding behavior, in their conception of avoiding predators and that sort of thing, which ultimately affects survivability. And then finally, I wanted to highlight Biscayne National Park's fishery management plan implementation. So in cooperation with FWC, the park has implemented a science plan that's actually looking to address increasing size and abundance of specific fish with species within the park boundary. And this is a first of its kind effort to kind of take a different approach in fisheries management and look at it more at a granular level. And then so to close and talk about take home message, we were talking about progress, talking about working to understand. FIU is getting ready to start, Jen Rahage's group is getting ready to start a great seagrass project to look at kind of how seagrass coverage affects fisheries and all of the things that support fisheries. And so they're going to be looking at some of your seagrass data over the years and trying to correlate that with prey items as well as fish abundance. So we'll be looking at that as well. So appreciate the time this morning and look forward to the rest of the conversation. Thanks.
All right, and finally, Dr. Jim Forkran, another associate director of the Institute of Environment at FIU and a world-renowned leader in seagrass ecology, and he's going to ad-lib to get us back on time.
That's right. So we had 4 20-minute presentations crammed into 40-minute sections. So thank you guys for leaving me no time. I'm going to try to go through this very quickly and not repeat things other people have already said, because I missed the slide. Because a number of my points have been made already, but let me start off by saying that when the descendants of Europeans first got to Fort Dallas and the Miami River, Biscayne Bay was seagrasses from one end to the other and all the way out to the reef tract. That was the natural state of things of Biscayne Bay, and that's what made it so productive and so attractive and brought Miami here in the first place. The end goal of all of our work should be getting that seagrass back across the entire landscape. What do we need to do that? We need clear water, because seagrasses need at least 25% of the sun's light reaching the bottom or they can't survive. We need to have no phosphorus coming into the system, because phosphorus flowing into the system makes the water less clear, so we don't get light to the bottom. If we don't have seagrasses there, we don't have the fish that people care about. And if we have pharmaceuticals coming in and killing the fish, well, it doesn't matter if you have seagrass there or not, right? Because the habitat value is bad. So we want to reestablish the habitats that should be here through our actions. Now, we've done a lot of things. There used to be rapids on the Miami River. We haven't talked all about the physical transformation of this system. Not only did we change the way water flowed into the bay on the surface, we changed the way it flowed in underground, and we changed the physical structure of the bay. We dredged and filled and removed seagrasses and piled up and made islands and made causeways. It's no wonder that the system is having trouble because of all the physical things we've done, in addition to all those water quality things that Pamela talked about. Don't know why that's blank. Okay, so I'm not gonna have any more slides. uh, Okay, so Irela talked about this, that is the trend line. Each of those colors is a different year. And you can see in the Julia Tuttle Basin, seagrasses have been retreating into shallower and shallower water from the north to the south because of that phosphorus pollution to the north and the slow decline in water quality. We're seeing that go on. And it's just a really bad time delay when we're late. Okay, what happens is not enough light reaches the bottom and the oxygen gets used up and we get sulfur bacteria going crazy, making hydrogen sulfide. It kills the grass. This is the same mechanism that killed the grass in Florida Bay back in the 1980s, but this one's being driven by nutrient pollution. I wish I even remembered the order of the slides so I can start talking about them before they come up. So what happens is seagrasses and corals are the slow growing things in our ecosystem, right? They grow slow, which means they don't need a lot of resources to grow because they're just sitting there most of the time. And then within the seagrasses, the turtle grass is the slowest growing, shoalweed is the fastest growing, macroalgae grows faster than that, and those harmful algal blooms grow faster than that. So as we add nutrients to the system, we increase resources and we shift the competitive balance over those microalgae, and we lose seagrasses because no light reaches the bottom. So we have to get that stopped. And there is a slide I need to show you because we haven't talked about. The loss of seagrasses is not a North Bay only phenomenon. Durham has a fabulous data set. This is what I said. Durham has a fabulous data set of going back 25 years of mapping the average. Go back one more. This is the average turtle grass density in those 5 time blocks of the southern part of the bay. And you see it gets less green as you go to more modern times. That's Thalassia going down and other species, other things on the bottom going up because that increase in nutrients. This is, you can't see it down there. Laura Reynolds has done these analyses. Laura, I think, is going to show this afternoon as well. This is the rate of change of turtle grass density along the South Dade shoreline over 25 years. The darkest one is 2.5% per year loss on average in the Durham data. So let me try to wrap up there and say it'd be great to get seagrasses back. We can get seagrasses back. We know how to do it. We have to stop putting phosphorus into the water that goes into the groundwater and comes out into Biscayne Bay. When we stop that, there's going to be a really slow loss of phosphorus in the system, and hopefully we can get back by the time my grandchildren's children are alive to the bay that was here when European settlers first got here. So thank you. I'm sorry. Todd also asked me to wrap up by saying we do have a new project coming online funded by DEP that is to try to put together a data portal to bring all the water quality data, all the hydrological data, all the seagrass distribution data, the animal data together into a single data source decision-making software program. And we're going to be running community workshops to get community involvement in this so we can design this not just for scientists, but for decision makers that need that information. So please look for, as soon as we get the funding actually in place, announcement of these workshops, and we'd love to have all of your input into designing a tool that we can all use. Thank you.
All right, join me in thanking the panel. Thanks very much. All right, we're scheduled to have a break, but while you guys are getting up and going to get donuts and coffee and stuff, I'm going to have the panelists stand here. Does anybody have any questions, any burning questions? But feel free to get up and go take a break. Yep. feel free to start your break. So Piero, I mean, you can answer that. I mean, yeah, I mean, I think the word is out that phosphorus is a bad thing, right? It's that you don't. Yeah, interesting. Okay.
So I have a response and a quick story for that. Years ago, can you hear me? Yeah. So years ago, when we first discovered that Florida Bay was phosphorus limited, it was one of the first phosphorus limited marine ecosystems in the world. And we made a splash in the scientific media, but the farmers all thought that this was a great thing. If Florida Bay is phosphorus limited, they should be able to dump all their waste phosphorus into the bay. And then it wouldn't be limited anymore. Well, the problem is the messaging part of the story is the systems we know and love require slow resources, slow nutrient delivery. And if you overpower them, you get things you don't want. You get the noxious weeds. So consider harmful algal blooms weeds in the otherwise beautiful garden. We want to keep them out so we can't put too much fertilizer in there.
What then we'll talk about how we can change the pattern. Talk a lot of something, they do something today. We don't talk a lot about mitigation. We're having an issue with on mitigation. We don't talk a lot about it. How do we stop our nasty hands from dumping on fruit?
Yeah, so you'll hear Arela in the Biscayne Bay Health Board. Education is one of our primary goals and needs, right? I think my neighbors in North Coral Gables don't have any idea that what happens in their backyard impacts the bay. They don't see the bay, they don't go to the bay, and they just don't have a sense of connectivity. And so I think one of our biggest challenges is to get everybody associated with the entire greater Biscayne Bay watershed to understand they're all part of that one system. And I just don't think people get it yet. Yeah. But it's talk about education, right? We talk about changing our culture. Yeah. And we don't talk enough about that. We want kids still continue to live how we lived 20, 30 years ago and talk about climate change as though it's something in the far future when we live in bad shape right now. Yeah, I think you're talking to the converted here. So thanks very much. Is that okay? All right. Okay.
Ladies and gentlemen, just one moment. We are live streaming this. If you're going to ask a question, you need to have a microphone in your hand, please.
I'm set. I hear my colleagues argue and other people argue about what the important sources of phosphorus and nitrogen are. And that I gather they're different in the upper part of the bay and the lower part of the bay, but how close are we to knowing the relative contributions of the different pollution sources? And what's it going to take for us to get there? That goes back to the being able to measure, being able to know what we know and measure what we can measure.
So I have to say that we are going in the right direction, but we're not there yet. So much of the projects that have been funded moving on do include a very heavy component on looking at source fingerprinting. We didn't do that in the past. We just measured the traditional things, right? So again, I said phosphorus is very boring. It doesn't even have an isotope that I can do anything with it. So it's very difficult to figure out where the phosphorus is coming from by itself. So I'm glad to report that at least DEP is thinking on measuring a number of other things that we can tie up as fingerprinting of that specific source of phosphorus. It's coming, but we don't know how difficult it's going to be until we try it. So I'm optimistic.
Thank you, Piero, for that. So we have a 15-minute break now, and a lot of you brought up very valid points. And there are many solutions providers downstairs, also representatives from FIU. So if you have any specific questions you have in mind that the panel couldn't get to, please feel free to meet them or others like them downstairs. Thank you. So 15 minutes.